Okay, everybody, welcome to the CXL Forum at OCP Summit. And I've got some slides that introduce the agenda and such, but we're going to use a different laptop for CMAC's presentation. So I'll come back and do a proper introduction after CMAC's presentation. But to kick off our forum today, we have Siamak Tavallaei, he's the president of the CXL Consortium and also chief architect over at Google, and he's going to give us an update on the CXL Consortium.
Good morning. Thank you very much for being here so early. We have a wonderful program today, all day, CXL Forum at OCP. I'm going to go over some of the exciting things that have been happening at CXL Consortium. You guys know that CXL Consortium formed with 9 original promoter companies, but soon we elected more directors, and we have now 15 companies from across the industry, CPU suppliers, system suppliers, hyperscalers, and now memory suppliers as well. So it has been a very good journey. We started in March 2019 as the CXL 1.0 was contributed first, and then immediately after that, more companies got together and added a compliance chapter and made it into CXL 1.1. More companies joined as contributors and members, and we basically started a team building activity around CXL 2.0. Added a few features, enough to make CXL more useful, but not too much so that we could in fact do it. With a good cadence in November 2020, with 130 members then, we introduced CXL 2.0. We thought that was great success, and then everybody got more energized, more use cases were introduced. Based on those new use cases, new capabilities were introduced, and just recently, during the Flash Memory Summit, we introduced and released CXL 3.0. It has a lot of features that I will go through in a minute. So the reason that we need CXL is that you guys know data is growing, competition requirements are growing in different fields, and hyperscalers and cloud suppliers are building larger and larger data centers. So that goes for the saying that we need to have better interconnects. Within the activities that we've had, now CXL is not just the specification, it is vibrant. Actually, on the show floor here, you will see companies that already have products. They're running them. There's a live demo in one of the booths over here you can go see. At Supercomputing, we had a very good showing. There are websites that you can dial in. After that, Intel Innovation Conference hosted a number of CXL suppliers, and OCP, as you see, there are a lot of good companies producing products. In addition to all of that, we have created a momentum. People are recognizing CXL is successful, and are joining efforts. First, companies joined the consortium. They worked together and then realized the work that has been done elsewhere, for example, Gen Z or OpenCAPI, is complementary to the work that's being done at CXL Consortium. So both Gen Z and OpenCAPI Consortium decided to move their assets to CXL. So all members and promoters of CXL specification can benefit from that. What that means is that individual technical staff will have access to all of those specifications to address the needs of use cases that are emerging around CXL. So again, to repeat that, use cases are emerging, data is growing, distances are growing, but some of the requirements remain the same. We need low latency, high performing interconnects to connect CPUs to memory, to storage devices, to networking devices, and GPUs to GPUs. What CXL 3.0 has added to enable a better interconnect includes capabilities for devices to be multi-ported so they can be connected to multiple hosts. The concept of fabric is introduced, and because of that, we have a fabric management concept to decompose systems and compose them back and produce capability for compute disaggregation. Memory pooling was introduced as part of CXL 2.0, but now CXL 3.0 extends that to memory sharing as well. In other words, a segment of memory of a particular device can be mapped to more than one host, many hosts. And through that, hosts can communicate. They can send data and packets from one host to another host. So bit rates have gone up from 32 gigabits per second to 64 gigatransfers per second using PAM4, still based on PCIe technology, so the physical layer is PCIe. So all in all, competition happens. You need to store data and you need to communicate it outside of a small envelope of a chassis, all the way to broadband networks. CXL fits right smack in the middle, not necessarily the lowest latency to the CPU cores, but not very far away either. So it is serving a purpose right in the middle where the CPUs and memory and GPUs reside. So a specific capability that we introduced in CXL 3.0 was to extend the number of devices of each type that can be connected to a switch. CXL 2.0 allowed many memory devices, type 3 devices, to be connected downstream from a switch, but only one caching device, the device that uses CXL.cache, to be connected to each port, a port of a CPU, a root port. But CXL 3.0 extends that, so it creates flexibility for composing larger fabrics. Having multiple layers of switches allows interesting topologies. You can have switches connected all to all, and the leaf nodes devices can be CPUs, memory devices, or accelerators, and that can create a very nice fabric. So a concept of spine and leaf can be created as well. Switches could be simple. They can be used for fan out if that's all the solution needed, or switches can participate in the fabric concept. We have several sessions today. We will go over the fabric capability of the switches later. A very important feature that was requested for CXL 3.0 was the capability for devices to talk to each other without having to go to the root port, without having to route cycles through the CPU complex. So that's the peer-to-peer capability within a hierarchy, within a coherence domain hierarchy. In this model, for example, host 2 creates a hierarchy of devices 1, device 2, device 5, and device 6. Within that hierarchy, devices can directly address each other, move data, and share the memory regions. CXL 3.0 also adds the sharing capability beyond pooling. The distinction between pooling and sharing Within pooling, you have a memory device. It can subdivide itself into multiple memory segments. Each memory segment can be mapped to only one host. That's a memory pooling device. Therefore, although a device is a multi-ported device, it looks like a single logical device to each one of those hosts. That is the simplest form of interconnect. Basically, we wanted to do no harm, make the simplest cases work well first. But then, because these devices are connected, it is logical to think, well, my device is connected to multiple hosts. Why wouldn't I be able to move data from one host to another host? That required coherence to work well. Because of that, the team has worked together and came up with a back invalidate channel for passing snoops. So having done that, now you can have a shared memory location that all of the hosts can touch, write to, and read from. On the coherence part of it, it can be handled through software coherence, but 3.0 allows hardware managed coherence as well. Now, putting it all together, you can have a switch that's connected to multiple hosts and multiple devices. Each device can subdivide itself to multiple memory segments. Some of the segments might be dedicated to each host, but some segments can be shared. And of course, the concept of security is important. Concept of fault tolerance is important for these devices to maintain. If we put them all together, you see the progression of CXL specification capabilities. 1.1 introduced the 68-byte FLIT and the notion of a type 1, type 2, and type 3 device. A type 3 device is the one that uses CXL.mem protocol, good for a memory controller, for example. A type 1 device is the one that is basically an accelerator and would like to initiate memory cycles. It uses CXL.cache protocol. And a device that can do both of those is a type 2 device. It's very likely that accelerators would like to have local memory and would like to be able to initiate cycles to touch CPU memory or device memory somewhere else. That would be a type 2 device. As I said earlier, CXL 2.0 added a few major features, capability for fan-out switches, capability for a global persistent flush so that persistent memory can be connected to the fabric and be assured that all of the data is flushed into persistence if you want to remove the part or if you want to bring a link down or if you want to close sessions. A notion of security is important, so CXL IDE was the one to provide a link level security on CXL fabric. And switches were introduced to do one layer of switching. But then 3.0 adds a number of other capabilities. First, the bit rate goes up from 32 gigabits per second to 64 PAM4 based on PCIe Gen 6 physical layer. And then other major attributes are the ones that memory can be directly addressed by peer devices over a switch in a hierarchy. Memory sharing now can happen using 256 byte FLIT. That's the capability that was possible through the back invalidate channel for snoops. And then devices can extend beyond only one dot cache per root port through a switch to many. So all in all, it creates a notion of a major capability through fabric. You can think of compute disaggregation, and then once you disaggregate memory from the compute elements, then the concept of composition of a system comes in hand. And there are a number of talks today that address the software aspects of what it means to do memory tiering and composition of systems. So The capabilities are there. We would like you guys all to participate. CXL membership has grown, but there are still a number of use cases of interest that the team really don't have time to complete. So CXL 3.0 has been released. The next version of the CXL will be a drop, perhaps 3.1 will be the next version of the specification that comes out to complete some of the work that we could not finish with 3.0. But then it will take some time before the 4.0 comes out. It needs help from a great community of talented people, come up with use cases and help solve the problems. So with that, I leave it back to Frank.
Thank you, Siamak. Before you step down, I just wanted to thank you one more time. This event, this is our third event, started at Flash Memory Summit, and it wouldn't happen without Siamak's passion for evangelizing CXL and for helping herd all the cats of the vendors and the organizations that are in, and I just want to thank you again, Siamak.
Thank you very much. And the passion that Frank talks about really is coming from you guys. When great passion comes in, people are actually doing hardware right now. It gives me some energy to do even more. Thank you.